Hello everyone. So welcome back. Today we have this question: sliding maximum window or sliding window maximum. Okay. See, the question says we are given an integer array and there is a sliding window of size k. Okay, that means we have a fixed size sliding window and that is moving from very left of the array to the right. Okay. Now uh, you can only see the k numbers in the window each time sliding window moves right by one position. Okay. See, for example, we need okay, let me discuss the question, what the question says. Okay, the question says we have an integer array and each time we can see, like here we have this integer array and the k is 3, so we each time we can see only the three elements, and within these three elements we need to find the maximum one. Which one is the maximum? 3 is the maximum, so we'll add 3 in our answer array. Similarly, we remove one to the right, we'll shift one to the right. Okay, so this one is our maximum, sorry, this one is our sliding window. We have to remove this one. Okay, so this one we have to ignore this one. So right now we have this one as our window, and here also we see that 3 is our maximum element, so we add 3. Now again we will shift towards one position right. Now now here, which one is our maximum? Obviously 5 is our maximum. Now again we add 5. Now again we shift by 1 towards the right. Again we have 5 as our maximum, so we add again 5. Now again we'll shift one position to right. Now we have 5, 3, 6. So here we have 6 as our maximum. Now we add 6. At last we have this one as our window size, sorry, window. Now here in this window we can see that 7 is our maximum, so we add 7, and we have reached the last because we cannot further shift towards the right. So this one is our answer. That means in each window we have to find the maximum element and put it in our answer array. Okay, so let's see how we can do this. See, one intuition is brute force. That means we have to put two for loops, nested for loops, and in that for loop, first I will be here, and j will also point to I, and j will run until 3. Means when the j hits the size of 3, it will have a maximum. It will have a maximum element, that is 3. Okay, it will maintain a maximum element 3, and it will add in our answer list. Now the inner while loop, inner for loop is it has hit the size of k, that is 3. So the inner while loop has, or the inner for loop has terminated. Now the I will shift towards 3, and j will again run from 3 to minus 3. So again we'll find that 3 is the maximum element, and we have hit the size of k, that is 3. So we'll add 3 here. Now the inner while loop or the inner for loop has terminated. Now again I will shift, that means the outer while loop, outer for loop will shift towards minus 1, and again the inner while loop or the inner for loop will run of size 3. That means 1 minus minus 1 minus 3 and 5. Now here we find that 5 is our maximum element. So this way we will run a for loop, or say two for loop that are nested. So each time, see, each time here we are traversing 1. Here we are traversing 3 2 times. Here we are traversing 1 3 times. See, here 1 is traversed 1 time. Here 1 is minus 1 is traversed 2 times. Here minus 1 is traversed minus 1 is traversed 3 times. Okay, so we can see, we can say that, we can say that we are running a loop approximately of big O of n squared times. Okay, that is approximately big O of n squared times, so that is not our optimal case. So in that case we need to find a solution which runs in log n, sorry, in linear time. That means just one iteration. Okay, so for that we need to improve, we need to take a space. So we'll take a q or dq. Okay, we'll take a dq, for example. Why dq? Because we can add from the first, we can add from the last, we can remove from the first, we can remove from the last in the dq. Okay, so we say that we'll store the maximum element in our front of the dq, or the front or the first element of the dq will store the maximum element, and at the last we'll insert all the craps, okay, that are not required. So at first we see the queue is empty. Okay, so we'll add the crap at the last. That is, we'll add -1 at the last. Okay, now we see that we reached here. Okay, we have two pointers. First one is our I, and J is also pointing to I right now. Okay, now we see that right now our queue was empty, so we add -1 here. Sorry, we add 1. The element J is pointing to 1. Sorry, J is pointing to the element 1, so we add 1 here. Now J shifts to 3, so now we'll see, is the queue empty? Queue is not empty. And now we'll check, is 3 less than 1? No, 3 is not less than 1, so we'll remove sorry, we'll remove 1. Now we see that the queue is empty, so now we'll add 3. Okay, we'll add 3. So this way we can find the maximum element. Okay, now again J goes here. Now we'll check, is 3 less than -1? No, 3 is not less than -1, so we'll not add -1. Will not add -1 here. So we'll add -1 at the last. Okay, we'll add -1 at the last. Sorry, I mean that 3 is not less than -1, so we'll not remove 3. We'll add -1 at the last. Okay, because we need to maintain the maximum element at the top of the queue. Okay, now see, we have reached this uh, k. Okay, the size of 3 we have reached. Now we'll remove the top element. Not remove, we'll pick out the top element and add in our answer list, or say answer array, because we know that the top element is the maximum one. So we'll add 3 here. Now we'll check, is 1 is present here? 1 is not present here. Why we are checking 1 is present here? Because we have hit the size of 3, of the 3. So now we have to shift our window to one more right position, and we'll have to remove this one. Okay, so right now 1 is not there, so that's no problem. Now now we'll check here, is 3 minus 3 is greater than 1? -1? No, it is not greater than -1, so simply add -3 at last. Okay, add -3 at last. Now again, size is hit. So we know that we have to remove this element. We have to remove the top element. Before removing that, we know that this one is our maximum element in this window. Okay, so we'll add 3 in our array, and then we remove the top element. Okay, now we have this one. Now we'll check, is 5 is greater than -3? Yeah, it is greater than -3, so remove -3. Now again we'll check, is 5 is greater than our last element, that is -1? Yeah, 5 is greater than -1, so remove -1. Now we'll check, is there any element left? No element left, so just add 5 at the last. So right now we have 5. Okay, we have hit this window, we have 5. Now 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 the top element is our answer, so add -5 in our answer array. Now in the next iteration we have this one. So our J points to 3. Now check, is 3 greater than 5? No, it's not greater than 5, so just add it at the last of the DQ. Now we know that the top element is our answer, so just add in our answer. Now see, we have hit this one element. We check, is -3 present? -3 is not present, so no worries. Shift our window. So now we will check, J is pointing to 6. Now we'll check, is 6 greater than 3? Yeah, so remove 3. Now again check, is the queue empty? Queue is not empty. Now check the last element, that is 5, is greater than 6? No, 6 is greater, so remove 5. Now again check, is the queue empty? Yeah, queue is empty, so now add 6 at the last. So now we know that the 6 is at last and at front only, so the first element is our answer, so add 6 in our answer array. Now 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 we have to remove 5, but 5 is already not there, so no worries. Shift our window. Now we see that J is pointing to 7. Now we'll see, is 7 greater than 6? Yeah, so remove 6. Now again add 7, and the top element is only 7. So add 7 in our answer, and now we see that j is pointing to the last index of the array. So now we have terminated the loop, and this answer is formed, and remove this answer array, sorry, return this answer array. Okay, okay, now see the code. So right now we have an answer array, that is this one. Okay, this one, sorry, this one, answer array, and and a dq for adding element in the top and at the last. Okay, dq is with dq we can add element at the front, at the last. We can also remove from the front and the last. Okay, so here we have run the for loop. Okay, and now we are checking, is the queue empty? Is the queue empty? Yeah, queue was empty. Queue was empty, so this one will not run. Okay, this one will not run. We'll simply add minus, sorry, we simply add one. Simply add one. Now this one will not hit because we are checking the window size using this if condition. Okay, right now our window size is just one. In the next iteration, in we'll check j goes here, j goes to 3, j goes to 3. We'll check, is 3 greater than 1? Is 3 greater than, yeah, 3 is greater than 1. And our queue is also not empty. Queue is not empty, and the current element is greater than the last element of queue, that is 1. Okay, see, the queue was having 1, and now we have 3 as our current element. J is pointing to 3. Okay, see, j plus plus, so j has point, j is pointing to 3. Now we'll check, is 3 is greater than the last element? Yeah, 3 is greater than the last element, so remove 1. Remove 1. Now we'll again check, is the queue empty? Yeah, queue is empty, so this one will not run. We simply jump to this line and add 3 here, add 3 here. Okay, now again our window size is not 3, so again j plus plus, j plus plus. Now j points to minus 1. Now we'll check, is minus 1 greater than greater than 3? No, no, so this loop will not run. Simply add minus 1 here, simply add minus 1 at the last of the dq. Now we have hit our window size, that is 3. So see, j is equals to 2, j 0 1 2, j is pointing, j is at index 2. So 2 minus I is equal to 0 right now. So 2 minus 0 is 0, plus 1 3, and 3 is equals to k. 3 is equal to k. So now we'll add the top element. See, dq dot peak first. We are adding the top element in our answer list. In our answer list, see, answer dot add, and we'll check, is I, array of I is present in our dq. See, dq is the first element, is our array of I? No, no. If it was our first element, then we have to remove, but it is not, so we'll not run this one. Okay, simply this will run n times, n times, and we'll get our array list. Okay, so let's run. Yeah, that is our answer. Submit it. Yeah, it will run. So I hope you understand our approach. Thanks for watching.